In previous session, I have explained and creation and insertion. Now, in this, I am going to explain how the item is displayed, that is operation performed on single linked list. What is this? Here, deletion in a single linked list. Here, what I am doing, I am explaining here deletion, search and display in this session. First, I am moving to the deletion. What is deletion? Deletion is nothing but in a single linked list, the deletion operation can be performed in three ways. What are those? Deleting from beginning of the list, then deleting from end of the list, that is in front end, and this is in rear end, and deleting at specific node, that means which I have node. What I should do deleting from the list, what I should follow? First, check whether list is empty. We can use the following step to delete a node from beginning of the single list. What are the steps I am following here? First, I will check whether list is empty. That means when head equals to null. Next, step 2. If it is empty, then display list is empty and deletion is not possible and terminate the function. Next, what is third step? If it is not empty, then define a node pointer temp and initialize with add. Have explained in previous sessions, because I cannot move head directly. For that reason, I am instead of head, I am taking a, or I have created another node, that is temp. Initially, I have assigned head temp equals to the head. Step 4, see here, check whether a list is having only one node, that is temp of next equals to null. If it is true, then head equals to null and delete the temp. That means if it is only one. Otherwise, if it is false, what I am doing, see here, as previously I am told that I am initializing head equals to temp of next and I will delete the temp. Next, deleting from the end of the list. We can use the following steps to delete a node from the end of the single linked list, that is in rear end. Check whether list is empty, that is head equals to null. If empty, then display list is empty, deletion is not possible and terminate the function. Next, if it is not empty, then define two node pointers, that is temp1 and temp2, and initialize temp1 with the add. Next, what I will do, I will check whether list has only one node, that is only temp1. If temp1 of next equals to null, if it is true, what happens, then the set head equals to null and delete temp1 and terminate the function. After that, I am setting empty list condition. Next, sixth one, if it is false, then set temp equals to temp2 equals to temp1 and move temp1 to its node. Repeat the same until it reaches last node in the list. That means when temp of next equals to null, I have said that in a linked list, if it is ends with null, that means it is a last node. Finally, set temp of 2 equals to null and equals to null and delete temporary. This temp2 of next equals to null and delete temp1. Next, if I want to delete at a specified node, deleting a specific node from the list, what I should follow? Check same condition here. If it is empty, that is head equals to null, it is empty. If it is empty, then display list is empty, deleting is not possible and terminate the function. If it is not empty, then define two node pointers, that is temp1 and temp2, and initialize temp1 with the add, because I am shifting the node, keeping moving the temp1 until it reaches to the exact node to be deleted or to the last node, and every time set temp2 equals to temp1. That I am initializing temp1 to the temp2 before moving the temp1 to its next node. This is very important. Before moving, I should make this one. Otherwise, it will be very problem. If it reaches to the last node, then display given node not found in the list and deletion is not possible and terminate the function. Next, last step, if it reaches to the exact node which we want to delete, then check whether list is having only one node or not. If it is having only one node, now I am setting head equals to null and I am deleting temp1. For deleting, we are using a inbuilt function that is free. I have told that in dynamic memory we are using malloc, calloc, realloc and free. Free is used to delete. Next step, if list contains multiple nodes, then check whether temp1, that is, if the first node in the list, that is temp equals to head, then if temp is the first node, then move to the head to the next node, that is head equals to head of next and delete temp1. Step 10. If temp1 is not first node, then check whether it is last node in the list, that is temp of temp of next equals to null. Next, if temp1 is last node, then set temp2 of next equals to null and delete temp1 and free the temp1. This is once again it is an inbuilt function. Here I have said free temp1, same concept is implemented here. If temp1 is not first node and not last node, then set temp2 next equals to temp1 of next and delete temp1 and free temp1. Searching is nothing but seeing whether desired element is found or not. If it is the element in the list, it is should show our element is found, and if it is not there, it should show that element is not there. Searching is performed in order to find the location of particular elements in the list. Searching an element in the list needs traversing through the list and make comparison of every element of the list with the specified element. If the element is matched with any other list element, then the location of element is returned from the function. For example, if I take here needs, I will search in this linked list. You assume that this is a linked list, then you can see here it is there. It will print this is the location, which location, and it will return. If I want to search my name here Guru Raj, here you cannot see that word and it will display item is searched. This is the Argle algorithm implemented. First step, ptr equals to head. Ptr is nothing but a pointer variable. I am setting I equals to 0. Then pointer equals to null. Write empty list. Go to step 8 and end of the if condition. In next, repeat step 5 to 7 until pointer is not equals to null. If pointer of data equals to item, write I plus 1. That is I am inserting and then end of if condition. Otherwise I equals to I plus 1. That means I am incrementing the ith element, that is the element which I have to be inserted. Then pointer equals to pointer of next. This is the value which stores the address. Then end of the loop, then exited. This is what C program here we are implementing. You can see the header files we have included, and we are using two here. One is to create and another one is to search. Struct node, I am creating a node, then I am assigning node as a head. Then main functions, I am see here I am taking a value to print what create, search, exit, then I will make an enter your choice. Here I have taken choices. First choice is to enter an item, that means I am creating an node and I am implementing an or insert item into an node. Then in case 2 I am searching an element, then exiting. There I am using do while loop. I have taken only 3 conditions. This is the creating in a node. First I am taking initially taking a memory by dynamic using dynamic allocation, that is malloc. Here I am checking if pointer is null, overflow, else what is doing, pointer of data item equals to item, then pointer of next equals to head, that is I am initializing head equals to pointer, and now this one will become the head and the node is in. Now I am searching an element struct node star pointer, that I am declaring the variable items, 3 items. One is item I and flag pointer equals to, I am initializing pointer as an head. If pointer equals to null, it is printing empty. If the condition is false, then it will come here. Then I am assigning pointer data equals to item. Item find out the specified location, that is I equals to I plus 1. I am returning flag value as 0. If it is false, then it will move flag equals to 1. I am incrementing I, then I am assigning pointer equals to pointer of next. If flag equals to 1, what it will do? It will print item not found. This is the output, how it has been created. You can see I have taken 4. I am entering in 23. Node is inserted. Next 34. Node is inserted. Next search 1. I am entering 34. Item found at the location 1. See here, you can see 34 and 23 is there. 34 first location, therefore it is found. For displaying, we can use this algorithms followed. Check whether list is empty. If head equals to null, what happens? It will print empty and display list is empty and terminate the function. If it is not empty, then it pointer variable temp is taken and initialized with the head. Then keep displaying from temp to data, which is an arrow mark. This is, you can see, until where temp reaches to the last node, that is the what is the last node link. Last node link is null. Now last step is finally display temp data with an arrow mark pointing null. Then temp of the data is tends to null, that means I have reached the last node. This is also a last node, which is I am ending in a session 36. Thank you.